Lesson 3, Determining Angle Measures. In this lesson, we're going to be using the following procedure to determine the measure of an angle given its trig ratio. Step number 1, we're going to figure out which quadrants our angle is going to lie in by using the cast rule. In step number 2, we will sketch our angle in the correct quadrants, and then we're going to figure out what the reference angles are by using the functions second sine, second cos, or second tan. And in our final step, once we have that reference angle, we're going to determine the measure of our angle in standard position. Example 1. Determine the measures of angle theta rounded to the nearest degree, where our angle needs to fall between 0 degrees and 360 degrees. When you look at your interval, if everything is being measured in degrees, that tells us that our calculator needs to be in degree mode. For A, we've got sine theta is equal to 0.3620. So our goal is to figure out what is our angle theta that's going to give us this particular ratio. So our first step is to figure out which quadrants we are working in. So if I use my cast rule, we want to figure out which quadrants is our ratio going to be positive for sine. In this case, we're going to eliminate quadrants 3 and quadrants 4 because sine will be negative in those quadrants. So we're going to draw two terminal arms. There's one possible answer where our terminal arm is in quadrant number 1. And we have a second possible answer where our terminal arm is in quadrant number 2. The next step is to find our reference angle. And in our calculator, we're going to type second sine and then 0.3620. And if you're in degree mode and you press enter, we're going to get 21.223073778 and so on. This is our reference angle. And in this case, we're just going to round to the nearest degree. So 21.22 is going to round to about 21 degrees. So our reference angle is the angle in between our terminal arm and the closest x-axis. So in quadrant number 1, our terminal arm is closest to the 0 degree x-axis. So 21 degrees is going to be that angle. And then in quadrant number 2, our terminal arm is going to be closest to the 180 degree axis. So that's also a reference angle of 21. So we have two solutions, one in quadrant 1 and the other solution is in quadrant number 2. So for angle 1, that will be the angle in quadrant number 1. So our terminal arm is 21 degrees above our x-axis. So all you'd have to do is take 21 degrees and then minus 0 degrees, which will just give us 21 degrees. So that's our first solution. For our second arm, we need to measure our standard angle from 0. So we're trying to figure out what is 0 all the way up to our terminal arm in quadrant number 2. So what we would have to do is, for angle 2, take 180 and then subtract that reference angle of 21, and the leftover will be equal to 159 degrees. So that means that starting from 0 up to our terminal arm in quadrant number 2 is an angle of 159 degrees. So our two solutions, 21 and 159. For B, we've got cotan theta is equal to negative 0.5774. Now, cotan is the reciprocal of tan, so I'm just going to rewrite this as tan theta. And if cotan theta is negative 0.5774 over 1, to get it back to tan, we just have to take the reciprocal of this fraction. So it's just going to end up becoming 1 over negative 0.5774. Now, we have to figure out which quadrants we're in. So again, with our cast rule, we want to figure out which quadrants would tan be negative in. So tan is positive in quadrants number 3, so we'll eliminate that one. And tan will also be positive in quadrant number 1, so I'm going to eliminate quadrant 1. So we'll have one terminal arm in quadrant number 2, and we'll have a second solution given a terminal arm in quadrant number 4. So now we have to figure out our reference angle, and in your calculator, we'll have to type this in as second tan, and then inside the brackets, we're just going to put in the positive version of the value. So I'm just going to type in 1 divided by 0.5774. And then out is going to pop 59.99, which is going to act as our reference angle, but I'm just going to round it to 60 degrees. So what this tells us is that for our terminal arm in quadrant number 2, the distance in between our terminal arm and the closest x-axis, being the 180 axis, that's going to be a reference angle of 60. And in quadrant number 4, our terminal arm is going to be closest to our 360-degree arm, and that is also an angle of 60. So to figure out angle number 1, our first solution, we're trying to figure out the angle between 0 and our terminal arm in quadrant number 2. So all we would have to do is take 180 and then subtract our reference angle of 60 degrees, and we get our first solution being 120 degrees. Now, for our second solution, I'll call that theta 2. We're trying to figure out our angle starting from 0 all the way up to the terminal arm in quadrant number 4. So because the terminal arm is closest to 360, I'm going to take 360 degrees, subtract away the reference angle of 60. So then whatever's left over is 300 degrees. So our second angle will be equal to 300 degrees. For C, we have cos theta is equal to 0. Now, 0 is neither positive nor negative. So what I'm going to do is just go straight into typing into our calculator cos inverse. So just type in second and then cos of 0, and we get a reference angle of 90. So if I were starting from 0 degrees, if I go up 90 degrees, what we land on is the y-axis on the top part of our grid. So our reference angle, if it's 90, okay, it's going to land on this arm here. So our first solution is just going to be 90 degrees. Our second solution, if I use the reference angle of 90 again, but I go the opposite direction, that means that our terminal arm is going to land on the y-axis on the bottom part of our grid. But our solution for theta 2, we always have to measure from 0. So if I started from 0 and I go up and then towards the left, going from 0 up to here is 90 degrees, and then halfway is 180. And then if we go another 90 to land at that terminal arm, we have an angle of 270 degrees. So our two solutions are 90 and 270. For D, I've got sine theta is equal to 0. So again, the cast rule is not going to help us very much because 0 is neither positive nor negative. So in my calculator, if I type in second sine and then 0, I get a reference angle of 0. So if my reference angle is 0, that means that my terminal arm lands right on the x-axis on the right side. So that means our first solution is just 0 degrees. 0 degrees. And then if I go and draw a reference angle of 0 degrees on the other side, again, we're not going up or down. We're landing right on 180 degrees. So that means that angle number 2 is equal to 180. So our two solutions are 0 and 180. For the your turn, we're going to find the measures of angle theta, again to the nearest degree, and we want our answers to fall in between 0 degrees and 360 degrees. So for A, I've got cos theta is equal to negative 0.8660. So first, we have to figure out which quadrants is cosine going to be negative in. So again, I'll use my cast rule. So we want cosine to be negative. So cosine is positive in quadrant 4, so we don't want that one. Cosine is also positive in quadrant 1, so we don't want that one either. So I'm going to draw a terminal arm in quadrant number 2, and I'll draw another terminal arm in quadrant number 3. So we'll have two solutions where cosine will be negative. Now, we'll need our reference angle. So in the calculator, I'm just going to type in second cos, and then I'll just take the positive version of that value. So second cos and then 0.8660. And then we get 30.0029 and so on. This is going to act as our reference angle. So I'm just going to round it to 30 degrees. So in quadrant number 2, our terminal arm is closest to the 180 degree axis. So I'll write a little 30 degrees in that quadrant. And then for the terminal arm in quadrant number 3, same thing. Up to the closest x-axis is our reference angle of 30. So our solutions should always be measured from 0. So if 0 degrees starts on the far right, 0 up to our terminal arm in quadrant number 2, we'll just need to take 180 degrees and then minus away our reference angle of 30, and that gives us our first solution being 150 degrees. And then from 0 up to our terminal arm in quadrant number 3, we will now have to take 180, but now we'll have to add an extra 30 degrees, and that nets us a angle of 210 degrees. So our two solutions are 150 degrees and 210 degrees. For B, we've got secant theta is equal to square root of 3. So I'm going to switch this back to its reciprocal form. So secant is the reciprocal of cosine. And if I treat secant theta of root 3 as root 3 over 1, then cosine of theta is just going to be the reciprocal of that, which is 1 over square root of 3. So first, let's figure out which quadrants we are in. So using our cast rule again, the only two quadrants where cosine are positive are quadrants 1 and quadrants 4. So I'm going to eliminate quadrants 2 and 3 for now. So our first terminal arm, I'll draw in quadrant 1. And then our second, I will draw in quadrant number 4. So quadrant 1, we're closest to 0 degrees, and in quadrant number 4, we're closest to 360 degrees. So next, let's figure out what our reference angle is. In the calculator, I'm going to type in second cos and then 1 divided by root 3, and we're going to get 54.735, which I'm going to round my reference angle to 55 degrees. So in quadrant number 1, up to the closest x-axis, we've got an angle here of 55 degrees. And then going the other way to our second terminal arm, that's also going to be 55 degrees. So our first solution in quadrant number 1, all we have to do is just take 55 degrees and then subtract 0. That's just going to give us 55 degrees. And then for solution 2, this time we have to take 360 degrees, and we are going to subtract 55 because we're trying to figure out the distance between 0 all the way up to our terminal arm in quadrant number 4. So 360 minus 55 degrees will give us an answer of 305 degrees. So our two solutions are 55 and 305. Example 2. Determine the measures of angle theta to the exact value where our angle theta has to be in between 0 and 2 pi. So when you look at your interval, because I'm dealing with 2 pi, that means that we should be in radian mode in our calculator. So for A, I've got sine of theta is equal to -1/2. First step, just like before, is to figure out which quadrants we are in. So if I want to figure out which quadrant sine is going to be negative in, that's going to happen in quadrant number 3 and quadrant number 4. So I'll just ignore quadrant 1 and quadrant 2. Now, we have to find our reference angle, but it's going to have to be in radians this time. So make sure that you're in radian mode first, and we're going to go second sine, and then just put in the positive value of 1/2. You're going to get a decimal of 0.5235 and so on. To get an exact value, what you're going to do is take that number, divide it by pi. You'll get 0.16 repeating. We're going to turn that into a fraction using our calculator. So just press math and then choose option number 1 for fraction. And then press enter, and we get 1/6. So what we're going to do is we're going to treat this as a reference angle of 1/6 times pi. But just to simplify it, I'm just going to write it as pi/6. This is going to act as our reference angle in radians. So in quadrant number 3, in terms of radians, the halfway mark is going to be pi radians. And then in quadrant number 4, we're going to be closest to 2 pi. So our reference angle, again, is in between our terminal arm and the closest x-axis. So in quadrant number 3, I've got my reference angle of pi over 6 over here. And in quadrant number 4, we're closest to that 2 pi x-axis. So this is going to be a reference angle of pi by 6 as well. And just like what we were doing before, we still need to find our solutions starting from 0. So for our first solution, we're going from 0 radians up to that terminal arm in quadrant number 3. So to find theta 1, so our first solution, I'm going to start with pi, and then I'm going to add that reference angle of pi over 6. Now to add these, I'm going to put the pi over 1. So we'll need a common denominator before we can add these together. So I just need to turn it into a common denominator of 6. So the first fraction, I'm just going to multiply by 6 on the top and bottom, which gives us 6 pi over 6 plus pi over 6. And we're just going to add the numerators together, giving us 7 pi over 6. So that is going to be our solution as an exact value in radians. And then for our second solution, if I'm measuring from 0 all the way up to our terminal arm in quadrant number 4, what we're going to do is start at 2 pi, and we're going to subtract that reference angle of pi by 6. I'll put the 2 pi over 1, and we'll need a common denominator of 6 once again, so I'll multiply the first fraction by 6 over 6. So we would end up having 12 pi over 6 minus pi over 6. So our solution for our terminal arm in quadrant number 4 is going to be 11 pi over 6. For B, we've got secant theta is equal to 2 divided by the square root of 2. I'm going to turn it into its reciprocal form. So the reciprocal of secant is cosine of theta. And if secant is 2 over square root of 2, cosine is just going to be the reciprocal of that. So I'll put the square root of 2 on top and then put the 2 on the bottom. So root 2 over 2. First, let's use our cast rule to figure out which quadrants we are working in. So cosine needs to be positive. So cosine is positive in quadrants 1 and quadrant 4. So I'm just going to ignore quadrant 2 and quadrant 3. So next is finding our reference angle in exact value. So in the calculator, we're going to press second, cos, and then square root of 2 divided by 2 inside the brackets. You're going to get a decimal value of 0.7853 and so on. But we want to turn this into an exact value. So take that number, divide it by pi, which gives us 0.25. And then in your calculator, just press math, 1, and then enter. And we get pi over 4. So what this means is that our reference angle is going to be pi multiplied by 1 over 4, which is really just equal to pi over 4. So in quadrant number 1, that terminal arm is closest to 0 radians. Sorry, there's no degree symbol. Oops. So it's just 0 radians. And between the x-axis and that terminal arm, we've got a reference angle of pi over 4. And in quadrant number 4, if I go down, okay, we're closest to our 2 pi arm. So that reference angle, again, is still pi over 4. So our first solution, that terminal arm in quadrant number 1, all we have to do is take pi by 4, pi divided by 4, and then we just subtract 0 radians, which is still just going to give us pi over 4. So that's our first solution. And for our second solution, if I'm measuring from 0 all the way up to the terminal arm in quadrant number 4, what we're going to do is take 2 pi, so the closest x-axis, and we're going to subtract pi over 4. Again, to subtract these, I'll put the 2 pi over 1, and we need a common denominator of 4, so I'll multiply that 2 pi over 1 by 4 on top and 4 on the bottom, which gives us 8 pi over 4 minus pi over 4. And 8 pi minus pi just gives us 7 pi over 4. So that is our second solution. Okay, we've got two questions for the your turn. Again, we're just finding the measures of angle theta as an exact value in radians, where our answer should fall in between 0 and 2 pi. So again, just make sure that your calculator is in radian mode. So for the first one, I've got tan theta is equal to 1. So if tan is equal to a positive 1, using our cast rule, tan is only going to be positive in quadrants 3 and quadrants 1. So this time we're ignoring quadrant 2 and quadrant 4. Next, we're going to find our reference angle. So we're going to type second, tan, and then 1. And when you press enter, you get a decimal of 0.7853 and so on. We're going to take that number, divide it by pi to get 0.25. And you're going to go math, 1, enter to get 1 over 4, which means that our reference angle is equal to pi multiplied by 1 over 4, which we can simplify to pi over 4. So measuring from 0 radians up to our first terminal arm in quadrant number 1, we'll have a reference angle of pi over 4. And in quadrant number 3, our terminal arm is closest to our pi axis. And in between those two arms is a reference angle of pi over 4. So our first solution, getting to that terminal arm in quadrant number 1, all you have to do is just take pi over 4 and then minus 0, which is just pi over 4. So that's answer number 1. And the second solution, if I want to look for the distance between 0 and the terminal arm in quadrant number 3, we're going to start with pi, and we're going to add that reference angle of pi over 4. Again, I will put the pi over 1, and we need a common denominator of 4 this time. So I'll multiply pi over 1 by 4 over 4, which gives us 4 pi over 4 plus pi over 4. So our solution, when we add these together, is 5 pi over 4. For B, we've got cosecant is equal to negative 2 over square root 3. So cosecant, we're going to turn it into its reciprocal form. So sine of theta is its reciprocal. And we just have to flip the top and bottom of 2 over root 3. So it'll still be negative, but this time we'll have square root 3 over 2. Now, using the cast rule, sine is only going to be negative in quadrant 3 and quadrant 4. So we'll ignore quadrant 1 and quadrant 2. Step 2, we're going to find our reference angle. So in your calculator, second sine, and then square root of 3 divided by 2, which gives us 1.047 and so on. And to get an exact value, we're going to divide it by pi, which gives us 0.3 repeating. And if you go math, enter, enter, we get 1/3, which means that our reference angle is pi multiplied by 1/3, which is just pi over 3. So in our third quadrant, our terminal arm is closest to pi. So the angle in between is our reference angle of pi over 3. The terminal arm in quadrant number 4 is closest to 2 pi. So then in between these two is pi over 3. Now our first solution, that terminal arm in quadrant number 3, we'll have to take pi and then add it to pi over 3. I'll put the pi over 1, and we need a common denominator of 3, so I'll multiply that fraction by 3 over 3, which gives us 3 pi over 3 plus pi over 3. And 3 pi plus pi gives us 4 pi over 3 as our first solution. For the terminal arm in quadrant number 4, this time we have to take 2 pi and then minus away the reference angle of pi over 3. So we'll go 2 pi minus pi over 3. I'll put 2 pi over 1. We need a common denominator of 3, so I'll multiply top and bottom of 2 pi over 1 by 3, which gives us 6 pi over 3 minus pi over 3, which is equal to 5 pi over 3. So our two solutions, 4 pi by 3 and 5 pi by 3. Example 3. Determine the measure of angle theta on a restricted domain. For A, I've got secant theta is equal to negative 5 over 4. But when you look at your interval, now we want our angles to be in between 180 degrees and 360 degrees. So instead of starting with 0, like we have for all of the other questions, this time we're actually only going to take answers that are greater than or equal to 180, but less than 360. So this is what it means to have a restricted domain. Now also pay attention to the numbers inside of your interval. Because we're dealing with 180 degrees and 360 degrees, our calculator needs to be turned back into degree mode. Now, to get to the question, I'm going to start by converting secant theta into its reciprocal form. So secant is the reciprocal of cosine. So that means the cosine theta is going to be equal to negative 4 over 5. So again, all I'm doing is just flipping the numerator and denominator. So we want to figure out where's cosine going to be negative. So again, using our cast rule, we want to only draw terminal arms in quadrants where cosine will be negative, which means that we're working with quadrants number 2 and quadrant number 4. 3. We're going to eliminate quadrant 1 and quadrant 4. Okay, now we need a reference angle. So in your calculator, just type second cos, and then just put in the positive 4 over 5 to get your reference angle. So we get about 36.869. So we're going to take a reference angle, rounding it to the nearest degree, of 37 degrees. So our terminal arm in quadrant number 2, it's going to be closest to this 180 degree mark. Here we would have to subtract our reference angle of 37 degrees. And in quadrant number 3, we would take 180 and then we would add our reference angle of 37 degrees. So our two solutions for now, theta 1. So the arm starting from 0 up to our terminal arm in quadrant number 2, I'll just take 180 and then minus 37 degrees. And that's going to give us 143 degrees. Now for our second solution, we want to figure out the distance from 0 all the way up to the terminal arm in quadrant number 3. So this time we're going to take 180 and we're going to add 37 degrees. That is going to give us 217 degrees. Now, when we look at our restricted domain, our solution can only be greater than or equal to 180 and less than 360. So even though we got two solutions, we're actually going to reject solution number 1 because 143 is less than 180 degrees, so it doesn't fall inside of our domain. So that means the only solution is 217 degrees. For B, we've got sine of theta is equal to negative square root 3 over 2. And this time, our restricted domain, our answer has to be in between 180 degrees and 270 degrees. So starting with our cast rule, we want to figure out which quadrants is sine going to be negative in. And it's going to be negative in quadrant 3 and quadrant 4. So we'll just ignore quadrant 1 and quadrant 2. Next is finding our reference angle. So type in second sine and then square root of 3 over 2. And that's going to give us a reference angle of 60 degrees. So in quadrant number 3, we're closest to the 180 degree axis. Okay, and in between those two arms is 60 degrees. In quadrant number 4, we are closest to 360 degrees. And the angle in between those two arms is 60 degrees. So measuring from 0. If I want to travel from 0 all the way up to that first terminal arm in quadrant number 3, we will have to take 180 and we add 60 degrees, which gives us 240 degrees. And then for angle 2, we want to go from 0 up to the terminal arm in quadrant number 4. So this time we're going to take 360 and we're going to subtract our reference angle of 60 degrees, which gives us an angle of 300 degrees. Now, when we look at our interval, our angle has to be in between 180 degrees and 270 degrees. So that means we're actually going to eliminate or reject angle 2, and we're only going to take our first solution, which is 240 degrees. For C, we've got cotan theta is equal to 1 over root 3. And our restricted domain is theta has to be greater than or equal to negative pi, but less than 0. When you look at your interval, because I see a negative pi in there, that tells us that our calculator needs to be in radian mode. So go ahead and switch that right now. Okay, dealing with cotan, I like to turn these back into their primary trig ratios. So the reciprocal of cotan is tan theta. And we just have to flip the numerator and denominator. So we're going to get tan theta is equal to square root 3 over 1. But root 3 divided by 1, I can just simplify to tan theta is equal to square root of 3. So that's going to be the ratio that we're going to work with. So let's use our cast rule. We want to figure out which quadrants are tan going to be positive in. So quadrant number 1 and quadrant number 3. So we'll ignore quadrants 2 and 4. Okay, our next step is finding our reference angle. So I've got second, 10, and then square root of 3. And then you'll get 1.047 and so on, which we'll take that value, and to get an exact value, we'll divide it by pi to give us 0.3 repeating. And if you go math 1 and then enter, we get 1/3. So what that means is that our reference angle is going to be equal to pi times 1 over 3, which is just pi over 3. Okay, the next part, this is going to be a little tricky. Because our solution has to fall in between negative pi and 0, I'm actually going to label my axes in the negative direction. So 0 is still on the far right, but if we go down and then towards the left, this will be negative pi over 2 radians. Halfway is negative pi radians. And then 3/4 of the way is negative 3 pi over 2. And all the way around is negative 2 pi. Now, our solution has to be bigger than negative pi, but less than 0. So what I'm going to do is I'm just going to focus on the area where we're starting at negative pi and then ending at 0. So our solution just has to fall inside of this purple box that I drew. So that first terminal arm in quadrant number 1, because it doesn't fall inside that box that I outlined, we don't even need to bother finding this angle because it's going to be less than negative pi, which we don't want. So we're actually only going to focus on the terminal arm in quadrant number 3. So between negative pi and our terminal arm, we've got a reference angle of pi over 3. So the solution that I'm going to find, I'll just call it theta 1. We're going to take negative pi. And again, here's where you want to be careful. Because we're starting from a negative pi and we're going down and then towards the right, we're actually going to add our reference angle of pi over 3. And we'll put that negative pi over 1. We'll need a common denominator of 3, so I'll multiply negative pi over 1 by 3 over 3, which gives us negative 3 pi over 3 plus pi over 3. So if we add those together, negative 3 pi plus pi gives us negative 2 pi over 3. And that is our solution. For D, we've got cos theta squared is equal to 3 over 4. And our interval, we want to make sure our answer falls in between pi and 2 pi. So again, when you see these pi's, just make sure your calculator is in radian mode. So this one's going to have one extra step. So I've got cos theta squared. What we're actually going to do is we're going to square root both sides just so that we can get rid of this power of 2. So on the left side, the square root will cancel out the power of 2, which leaves us with cosine of theta. And if I were to square root 3 over 4, square root of 3 over 4 is the same thing as square root of 3 divided by the square root of 4. So all I'm doing is I'm just splitting up the square root symbol to cover the numerator and to cover the denominator. So the trig ratio that we're actually going to work with is just cosine theta is equal to root 3 over root 4. And on the bottom, square root of 4 just equals 2. So we can actually simplify this to square root of 3 over 2. Okay, so now using our cast rule, let's figure out which quadrants cosine is going to be positive in. So it's going to be positive in quadrant number 1, and it's going to be positive in quadrant number 4. Now, when I label my axes in radians, I've got 0, pi by 2, pi, 3 pi by 2, and 2 pi. Now, if I look at my intervals, my answer needs to fall in between pi and 2 pi. Okay, I don't want anything smaller than pi. So I am actually only going to worry about anything that falls inside of this dark blue region that I'm outlining, because we want to go only from pi up to 2 pi. So because this terminal arm in quadrant number 1 falls outside of that box, we don't even need to find it, we'll just ignore it. So the only angle that we need to find is 0 all the way up to the terminal arm in quadrant number 4. Now we need to find the reference angle. So we'll go second cos and then root 3 divided by 2. And we'll take that decimal and divide it by pi to get an exact value. And when you go math, enter, you'll get pi over 6, which means that our reference angle is going to be equal to pi times 1 over 6, which is equal to pi over 6. So in between our terminal arm and the 2 pi axis, that's going to be a reference angle of pi over 6. So to get our solution, we are going to take 2 pi and we're going to subtract pi over 6. I'll put the 2 pi over 1 as always, and we'll need to get a common denominator of 6. So we will multiply the top and bottom by 6, which gives us 12 pi over 6 minus pi over 6. So our solution is going to be 11 pi over 6.